So, for instance, writing tests in Python would be a wonderful topic, right? Or writing, I think I will present, but someone could even join me writing text processing utilities in Python. So these people, as I said, are pretty much beginners, and they'd definitely be interested in the projects you've got. I probably should have brought my other set of glasses. Well, what do you think? It's time to upgrade the Mac OS? Well, you guys can watch while that happens. Well, I guess we'll hold off, huh? So the DevOps course.com. Okay. So I'm going to talk about infrastructure as code. How is our display big enough? How's it look? You're not down and out with Vivek? You made it today, huh? All right. So we have a wonderful little video. This is only a couple minutes long. You should watch this if you can. The fellow talks about why to do infrastructure as code. One of the DevOps principles that Dennis talked about was to do everything as code. So we want to test our software. What are our tests? What are our tests? Code. Thank you. Thank you. Our tests are code. When we want to make our help files, how do we make our help files? Code, right. The project that Ujia's team is working on, if we think of everything as code, what's your project doing? As code, right. We're doing graphics as code. This is something that I haven't seen a big push on, but I think it makes sense. It's in line with the everything is code idea. So what can we do when we turn these things into code? They're automated. We can reuse them very easily. It's much easier to reuse a function that does a circle chart of arrows pointing at some process than it is to copy the graphics, right? We can test them in an automated fashion. We can check them in. We can put them under version control and see at what point these things change. Deployment is faster so for infrastructure as code, the basic idea here is that we configure our machines with code. We set up our network. Wow, this is going to be annoying. We better stop this screen save thing from doing this every few seconds. So, system preferences. We've got to go to desktop and screensaver, or is it energy? No. I switched, 30 minutes, so it's the energy saver. Where is energy? Ah, there we go. Display sleep 1 minute. God. Okay. That should put a stop to that. But one reason that I like to stress that this fellow didn't is this last one. If we ask people to behave like automatons, Dennis was calling this monkey work. But I would call it machine work. That's the work we want the machine to do. Boring, repetitive work. Let the machine do the boring, repetitive work, right? We want to do the interesting stuff. Figuring out how to write code to automate something is interesting. I don't know, it's interesting to me, and hopefully if you want to become a software engineer, it's the kind of thing you probably ought to find interesting. If you don't, maybe you should become a doctor or a lawyer or something else, right? If this kind of stuff is boring to you, it's probably the wrong profession to go into. But in general, thinking through, we're solving a puzzle. How can I automate this? How can I make this happen at the push of a button, or at every 1 hour, rather than doing these boring, repetitive tasks yourself? So this is the reason why we want to do infrastructure as code. Section 2 has a bunch of available tools, and those are good to know about. The one we're going to focus on is Docker, and we're going to do some interactive work. So let's start by doing this. Okay, people hopefully have Docker installed. If you haven't cloned the online DevOps repo, if you could clone that now, just because we've got a container that I know we can work in. So, yes, Akshay. Zoom it? Yeah. Well, you guys, so you clone it to wherever you want it to be in your system. By the way, Prashant was one of my TAs, and he wound up, he's works with Docker almost full time. He's at IBM, and they've got a team doing Docker kind of work and configuring containers and swarms of containers with Kubernetes, pods of containers. So once you're in, once you've cloned the repo, you can cd into the directory you put it in, and then from in there, I'm going to try to run, let's see, I'm going to get the new stuff because I changed the container name last night. Okay, so I'm going to try to run the container. Okay, so we get unable to find image. DevOps latest. So what this is trying to do, let's look at what container.sh does. So it's just a little automation of, oh, sorry, we don't want to car it, we want to cat it. This is just a tiny bit of automation that runs the container. What it does is it first, if you already have the container running, so let's look at this about Docker. And so what we have here is an image. And then this runs and it becomes a container. It's like having Microsoft Word sitting on your disk. You're not running Microsoft Word. The image is just the static version. The container is the image up and running and available for doing something. So what this is doing is it's first removing any existing container, because you can't run two containers with the same name, right? Because if you try to address the container, Docker's not going to know which container you're addressing. And what we do is this sends standard error to dev null. That's called the bit bucket. It just is a way to chuck away the error messages, because if DevOps isn't running, this command will fail. And we don't want to scare people with a warning, DevOps not found. And they go, what? What happened? Nothing happened. It wasn't already running. So this just clears it out for you. And then we OR this with true. The reason we do that is so the command won't fail. So anything ORed with true, and true in shell is 0, anything ORed with true looks like it worked. So we just want to clear this out for you if it's running. If it's not, the command will fail, and we don't mind, right? That just means it wasn't already running. The container wasn't up. This is going to do Docker run. Interactive IT is terminal, I believe. This sets an environment variable. We can pass in environment variables into the container. And this says use MySQL equals 0, because locally I want to run with the SQLite database. This is mapping a port. It says map port 8000 in the container to port 8000 outside the container. So from outside we can access the whatever's running inside at port 8000. This says we're going to mount a volume. We're going to mount the current directory to home DevOps. The container's name is going to be DevOps. And what the container is going to do when it comes up is to run bash. But this failed. Why? I don't have the image. So everything is code. Our builds for the various things we need built are code, right? So if there's some artifact of the project, and that artifact can be constructed from other parts, we put it in a build script. We're using Make, but there's other things like Ant and Maven that can do this. This just happens to be, it's free, it's widely available, and I've used it for years, so I know it well. So we're using Make. So we're going to make the container. And this is building the image. So we'll take a look. So this is doing a Docker build. I don't recall what the -T flag does, but you can look this up easily enough. It's going to build a container named DevOps, and it's going to look in the Docker directory for instructions on how to build it. One of the things that made Docker a success, containers were around in Linux for I think a decade or so before Docker came out. Docker succeeded and really exploded into the world of software development because it allowed you to layer the containers and build on top of existing containers to create a new one. So what we have is we're building on top of a container called Python 3.6, which is available on Docker Hub, which is like GitHub for Docker containers. And building the container, the image, we're building the image. It takes a little while, but it only needs to be done when it's updated. So you don't need to do this every time you want to run it. It would be extremely time consuming. No one would use containers if you had to do that. Okay, so we succeeded. Let's take a look at what we used to build this. The image is built from two files, a Docker file and requirements.txt. So The Docker file is very simple instructions on what to do. This says from Python 3.6. That means our base container is 3.6. And that's built on top of other containers. It's built, for instance, on top of some Linux distribution. I haven't looked to see which one, but we can find out in a minute when we go in the container. We'll look and see what distribution we're running. It copies the requirements file into the container. Then it runs pip install upgrade pip. Do you know why this was written to upgrade pip every time?
Because the actual container with the Python 3.6, it has an older version.
All right, so we had an older pip in there. We probably, yeah. Okay, so we upgrade pip, and then we install everything in requirements, and then we set our working directory to home DevOps. So very simple, but notice the way we build the Docker container, we don't click on a bunch of buttons on screen. This was a popular way to try to do your infrastructure. Microsoft was pushing this. Everything would be GUI based. You'd go into Windows and you'd say, I want this server set up like this. Click on this, choose this option. This was popular, but then there was a fight inside Microsoft that finally resulted in Windows PowerShell being built. At first, Microsoft didn't want to do PowerShell. Some people did. And they said, no, we're the point-and-click people. We don't do scripts. And they finally got convinced that they needed a scripting language. They needed to automate these things, and they needed to do this as code. We have a very simple script that we can check in, put under version control, see what's changed in it. We could automatically process it with text processing tools. And then we have our requirements file. And this just says what has to go in the container. So inside the container, we want all these things. So we have established our working environment with some files of code. And if someone changes something, let's say someone changed one of these settings and broke the container. Let me point out now, we're using the container chiefly for development, but a major use of containers is to make the development environment and production environment the same. So a lot of people are working in a container, then shipping it up to AWS or Google Cloud or Azure. And we're not doing that at the moment because our server is running on Python Anywhere, and Python Anywhere doesn't support deployment of containers. But we'll do cloud deployment, and at that point we can just push the container up into the cloud and run the app in the same environment that's run on the laptop of the developer. And if something changes and all of a sudden this thing is up and running and it breaks, right? We can look at the requirements and say, uh-oh, someone changed to Django 2.2, and we haven't tested that yet. So because this is under version control, we can compare and see what changed and easily roll back a change, which is not very easy to do if you're pointing and clicking on things to do your setup. It's much more difficult to see what changed and to roll back a change. So now that we've built the container, now we should be able to run it. So now we can run container.sh if you're on Mac or Linux. If you're on Windows, you can just run the command that's inside container.sh. Again, this is just a way of automating the running. Oh, we're in the Docker directory. Need to go up, cat container. So if you're on Windows, you just run this command. And we could, I don't know if we have, What's the PowerShell extension? PSH? PS. PS1. So we do have a PowerShell script. I don't know if people have kept that up to date. I think it's probably missing the environment variable. So if you're on Windows, it's best off just running this command directly. But Akshay, we should make a note to update the PowerShell script as well. So now I'm going to enter the container. So we're now taking the image we built and activating it in memory. So it's actually launched, and we see that our prompt changed, and I want to kick off a second shell. So if you're on a Unix-based system like a Mac, it would be easy to follow along with this. So I would say please do. If you're on Windows, I'm not a Windows shell user, so I'm not sure what the equivalent commands would be. Sometimes they're the same as the Unix commands. Sometimes they're not. Okay, so we've got two shells. In one of them, we're inside the container we just built. In the other, we're running in my Mac. So what does it mean to be inside a container? I'm going to give you a hands-on understanding, then we'll discuss it theoretically a little bit. So if I run ls of the top-level directory, ls, and this is the root of the whole file system, /. Here's what my directory, my top-level directory on my Macintosh looks like. Inside the container, I'm going to make the font a little bigger here. If we do we have a quite different look to what the top-level file system looks like. Bin, dev, home, lib64, mount, proc, boot. We have bin. We don't have much overlap, dev, etc, right? There's a little bit of overlap, but you can see it's quite different file system, right? So I'm asking for what the root of the file system is, and it's different between inside the container and outside. This is one of the Linux capabilities. This is a general Unix capability that containers rely on. It's called change root. And what it does is you can restrict a user to a particular subset of the file system. So this is a great April Fool's joke for your sysadmin. We did this one year. It was a development environment where a lot of people had the root password. So we got in on April 1st before the sysadmin did. And what we did was we built an empty directory under his home directory. And then in the empty directory, we put a single directory called bin. And in there, we copied in a single program, ls. And then we changed his root directory to this empty directory. So a little later in the morning, when he got in and logged in, he first of all he's not in his usual home directory. So he's going to be surprised, and the first thing he's going to do is run pwd, print working directory. And he tries pwd, and it says, command not found. So the print working directory command is missing. And at this point, he's panicking. He's going, oh my God, how could the print working directory command be missing? And he runs ls, which is the only command we've given him to see what's around. And he's going to find he's in a completely empty file system, looking like it's the hard disk of the machine. And the only thing left in the whole file system are a bin directory and the ls command. So we had a little bit of fun with the sysadmin that morning, and then we said, April Fools, you're fine, we just change rooted you. So this is one of the Unix capabilities that this is taking advantage of. The Docker container is running as a changed root user and has its own file system. The other thing that Linux has that Docker took advantage of was virtual namespaces. So there are a whole bunch of tables in the Linux kernel holding information on things like what processes are running, what network connections do you have, things like that. And the Linux operating system gives you the ability to run a process with its own virtual namespaces that are unique to that process. So, for instance, if we go to look and see what processes are running. So, on my Mac, I get a big old list. The easiest thing to do here to get a sense of how many processes we're running is I'm going to take the ps command, the EF flags. Those are one of the flags that I've used them for so long I completely forget what they stand for, but they result in showing everything. And we pipe that through word count and ask for just a count of lines. So this is a Unix pipeline. We connect the output of this process into the input of this process, and we're going to get 262 processes running on my Mac. One of them will be Docker. So let's see, we can grep for Docker. Well, we actually have a number of Docker processes, but one of the processes running is this container, right? We can see the container right here. Now we're going to do the same command inside the container. Inside the container, we only see two things. This is the container's virtual namespace. It has its own process table. It doesn't see all these processes we're running on the Mac. It sees the bash shell and the ps command I just ran. That's it. We want to find out what machine we're on, or who we are. Let's, on the Mac, I'm gcala. In the container, my name is blank. We can see what machine we're running on. We can get information about the machine, its internet address, what release we have. So run uname -a, that's a flag for show all the information. We're running Darwin, which is the Mac OS kernel. We're getting a internet address from a dynamic pool of wireless internet addresses that NYU has. Darwin kernel version. So we get a bunch of information about the operating system. When we ask this inside the container, we're not running Darwin anymore. We're running Linux, GNU Linux. I don't see any more. I thought we might see something like Ubuntu or something in there, but we don't. In any case, what we see as our operating system in the container is Linux. So our host name is this name assigned from the wireless pool. inside the container, our host name is this hash value that Docker created. So we're a different host. So one thing that we can do with this is we've got a development environment set up, for instance, for Windows users who would not normally be able to run make. They'd have to install some special set of bash tools. Now they can run Linux and we'll have everything here installed they want. But another thing we can do is actually bring up the web server running our app, and we had no issues. So the web server comes up inside the container. It thinks this is its IP address. Outside the container, that's going to appear as 127.0.0.1. And this is a version of the server running our course that's running from inside the container. From outside the container, I can access it on the local host address. We can, of course, access web pages without running anything. But here we've got a back end that's running Django. The full setup we have now, this is a setup using SQLite database, but the full setup, which we'll look at, actually uses MySQL and Django running in two separate containers set up on a virtual network that Docker sets up, talking to each other. So this is a major use for Docker. The setup we have with a MySQL database and a Django server is a minor, it's a rather low level of complication. Typically in development, you might have a load balancer, an authentication server, a database server, a web server. So the development environment might involve 4 or 5 servers. How can someone on their laptop be able to rapidly test changes in an environment like this? Well, the fact that we can do compositions of Docker containers and bring up all 5 containers the person needs as if they were all on a network, right? Because these things talk to each other over a network when they're in production. Docker can duplicate that and make them think they're all talking to each other over a network, all running on the developer's laptop. Okay, so I'm going to bring down this one, and we will exit this container. All right, we've covered this material. Okay, let's look at some Docker commands. Let's run the container again, just so we've got something up. And here I'm going to do Docker PS. Oops, Docker PS. And we see one thing running. It's running bash. Its name is DevOps. It's been up for 7 seconds. We could also do Docker PS -a. That gives us all. We see that we've got this container running, this container, That's been up 29 seconds. We have another one that exited 56 seconds ago. So we can see what images are available. So this, I just installed Docker on this machine last night, so we don't have much in the way of images. I brought in this box because it's appeared hard to get my Linux laptop to connect to the display. When we were doing the video on Make, it took about a half hour to get it to work with the display, and I didn't want to put you all through that. So this is a listing from Prashant's machine. He had a fair number more images than I have. So Prashant worked out a little interactive session, and I'd like to go through that. So if you would try to follow along here, we're going to run docker pull nginx. Okay, so from Docker Hub, we're grabbing the image called nginx. You should run this yourselves if you would care to. So we've now gotten nginx latest by default. It'll always go for the latest. You can ask for a particular version if you know that there's something other than the latest you want. And now if we run Docker images, we see, so we have DevOps. We should resize this a little, so the display looks nicer. We can do, that's better, So we now have 3 images. DevOps, that's the one we've been running, nginx, and Python 3.6. Why do we have Python 3.6? Yes. Right. We built DevOps on top of Python 3.6, so it pulled Python 3.6 as the starting point. Again, this is one of the great achievements of Docker, that Docker allows us to build our container, our images, on top of existing images. So we don't need to worry about, okay, what's everything we need to do to get Python 3.6 running? That's done for us already, right? And then we just built our DevOps container on top of that. Okay. So now nginx pull shows up. I have this cloned, but what Prashant was doing was cloning our algorithms website. So we're actually going to make a container that will run this. So you should clone this as well. Well, it would really be sufficient. Whoops. All right, well. In any case, you can find it. Here, it would really be fine to clone any static website, but we might as well stick to the same one. So it's github.com gcala algorithms. So you're going to clone that wherever you'd like on your machine. So put up your hand at the point you've managed to get that cloned, so I know where people stand. So once you've completed cloning that, raise your hand and I'll get a sense for, I saw you, thank you. Okay, great. Get a sense for how far along people are. GitHub.com, GCala algorithms. Super. We're about halfway, I think, so we'll take another minute or two. Thank you, Mayank. How's it going? Mandy, you have it? Yeah. Karina? Good. Okay. I think people pretty much Manjar. You have it? Excellent. Okay. So now that you've got that cloned, the next thing to do okay, so we can actually simplify this a little bit. So what do we do in the shell script? We do, is there parentheses, PWD?
Yeah.
Okay, if you go into the directory where you just cloned this, we should be able to simplify the command here. Oh no, no parens. Parens, that would be make. Okay, so Prashant typed out the whole directory path to where he had cloned algorithms. But I think Akshay actually found this shortcut, which is handy. So what we're going to do now that we've cloned it, cd into the directory where you cloned it, and then we're going to do this command, except instead of users, Prashant, school, algos, we're going to do $pwd. A lot less typing, right? It's a lot less error prone. You always want to take advantage of these shortcuts, not just to save yourself time, but because it's hard to make the mistake typing 4 characters. It's much easier typing that entire path. So this section right here, let me highlight it. I can't draw on this, but I can highlight this part. And this is just wrapping because the line is too long. This is all one line, these two. It's just wrapped because we don't have enough screen space. This highlighted part, you're going to replace with $pwd. And then colon and user share nginx html minus d nginx. So let me run this too. We can see if there's any problems. Oops, I want to go into the algorithm directory, don't I? What the -v is doing is mapping the algorithms directory into the user share nginx HTML directory. So this says different web servers have different conventions for where their web pages live. I'm not an experienced nginx user, but clearly it wants its web pages in a directory that has this path. So we're going to run the container. Now this, I ran this, right? There's no bash specified here. So we're right back at my prompt. So we might wonder if it worked at all. Well, first thing we can do is run docker ps. And indeed, we have an Nginx container up and running. So how many people have been able to do the docker run command? Okay. Anyone having trouble could ask for help. Akshay, maybe you could, if anyone is stuck, you could take a look and see what they're stuck on. So you see the way I ran it, I copied everything from the website except instead of typing the whole path that Prashant typed, I typed pwd. And you have to do that from inside the place you clone the algorithms repo, because otherwise the working directory is going to be something different. You're not going to get the algorithms website. And again, this is all one line. It's just wrapping because of the limits of the screen size. So here is the command again. And this is the part that gets replaced with pwd. Is anyone stuck? Anyone having trouble running the container? Because Akshay can jump in and see where you're having trouble. Okay. I'll take that as everyone's A-OK. And now what we want to see Prashant contends that if we put this in the browser, we see the algorithms website. So if you ran the container successfully on localhost :880, you should find the algorithms website. So how many people have successfully hit the algorithms website? Excellent. Again, if you're stuck, don't hesitate to ask for help.
Localhost
:880. 8080, sorry, 8080, not 880, 8080. Oh, yeah, for Windows, sorry. Prashant, in fact, notes that. I apologize. I'm being Unix-centric here. Windows, it's 192.168.99.100, 880. So if you have Windows, you do indeed need to put something different in your web address field. And that's what let me highlight that for you.
It's still not accessing the page. It's saying that the site cannot be reached, even though the line for
Okay.
it did compile run correctly.
All right, well, Akshay will take a look. How you doing, Karina? You're stuck? Oh, well, is Docker installed?
Yes.
Okay.
And I'm still stuck on the very first step, unable to find the latest DevOps.
So
And then it
you need
says-
to run make container. You're on Windows,
I'm on
but you're,
Linux.
okay, great. Make the container.
Oh, it's a
I don't know why I got this page. Also, why I got this
You're,
camera.
yes, you're not mapping, okay, so PWD was capitals, and you type lowercase.
Oh, okay.
So, you run, let me show you how to stop and get rid of the container. So we see when we run Docker PS that we have Nginx running. Now I'm going to stop it. Docker, what did we stop by? The hash value? Oh, it's from the, we use the container ID, so, okay. So the name of the container wasn't Nginx, that's just the image that's running. The container name was this hash value. So I run docker stop and the hash value, and it stopped it. Now I can run docker rm. So if you ran the container, but you're not hitting the website, you can stop the container and then remove it, and then correct the command and rerun it. If you try to rerun it, well, it'll probably generate you probably get a second instance, because it's not going to have a name conflict, because it's just the hash value. But you might as well stop it and remove it, yes.
Have a name conflict because the name is algo_website.
All right, okay, yeah, so it does, all right. Right, he did give it a name, so right, you would have a name conflict. So you should be able to, if something went wrong launching the website, you can stop the container, you can remove it. I used the hash, we could have used algo website, and then you can rerun it. So I'm just going to scroll back. So if we go and if I try to refresh that web page right now,
That's probably just the wrong URL. Yeah. We're pretty sure it's the wrong URL.
for Windows?
Yeah.
Okay. Yeah, I'm not a Windows user. Prashant put that in, and I was taking his word for it. What you could do is Google for what IP address Nginx uses on Windows by default. That should do it. So I stopped the container. Now if I try to access that web page again, I get Safari can't connect to the server. Yes, Cindy?
So for Windows, instead of putting 127.0.0.1, put 0.0.0.0.
All zeros. Okay. Wonderful. So we'll have to correct our web page on this. Thomas, do you have a piece of scrap paper? And what, Rodrigo, do you have the time?
12 p.m.
Okay, so we're getting close to being done. Thank you, Thomas. Okay. So I'm going to relaunch the container. If we do Docker PS, we find it's not running. We are still running the DevOps container, but we're not, in the DevOps container, we're not actually running the web server at the moment. Otherwise, we'd have a conflict on what IP address they would both be trying to run on the same IP address. So did uppercase PWD sort that out? Yeah, great. Unix is case sensitive. So that's something that's Windows users may not be used to, so you do have to get the case right. So I bring the container up again, and I reconnect, and now the web server's back. So what we did was we got an image for the Nginx web server. We loaded, using the volume mount, the -v, we loaded the algorithms repo into the directory where Nginx expects to find its HTML pages, and by default it goes to index.html. Then we bring up the Nginx web server, and the website is where we expect it to be. So this was a small exercise in grabbing a Docker container, putting something in it we need, running it, and accessing that something. You've got the examples that are in our projects. We're going to try to standardize on container.sh and container.ps1 for the scripts that run the container. And then we're going to try to standardize on runserver.sh if that project runs a Django server, and that should bring up the Django server. So you've got examples, and then each project should have a directory called Docker with a Docker file and a requirements.txt. So you can look around our projects and see the different setups that different projects have for using Docker. The last thing we're going to do is take a look at, we've already looked at our Docker implementation for most of the projects. That's the Docker file and requirements.txt. The DevOps course itself is using Docker Compose to define and run an application composed of more than one Docker container. Docker Compose uses a YAML file. YAML is a simple specification language often used for configuration. And we're going to take a look at what the YAML file looks like. It's got the extension .yml, but it's always said YAML. SQLite is a file-based database, very simple. It's adequate for the purposes we've been using it for, but for more advanced stuff, you're going to want a real database like MySQL that's running as its own server. And Django can communicate to that database, and that's a much more realistic production-type setup. So the team working on the DevOps course has pushed things along to the point where our production setup runs a MySQL database and a Django server as separate processes that talk to each other. So now once you've got that in production, you're going to want your development environment to mirror that, at least for your final testing, because if you're not really testing what the actual application is going to be like. So what that team has done is make a Docker composition. I don't know if people call them compositions, what Docker Compose does, but it makes sense to call them compositions. So I call them compositions. And what happens is when you run the Docker Compose up, it brings up the MySQL database and the Django server, and as if they were out on a network, and you have the web server talk to the Django server, and the Django server talks to the database. And I'm just going to show you the YAML file. And we'll make this a bit bigger. So we've got a couple problems in here that I am pushing the team to address. For instance, this isn't a good idea, right? We've got plain text passwords in a file checked into version control. So we're going to have to fix that. But what this says is this Docker Compose file has these services in it. One of them's a database engine. It runs the image MySQL. It gives the container the name dbEngine. It runs this command, mounts this volume, runs on this port. It's going to use the DevOps network. This is a network Docker is going to build for these two containers. Restart always. If it crashes, always bring it back up. And here, this sets up the environment for it. And it has a health check. This is a way to see if the database is in fact up, so that you can, if it's crashed, you can kill the process and restart it. The other service is DevOps app. DevOps app has a Docker file, Django container.yaml, always restart. The container name is DevOps app. It runs on port 8000. Its volume is home DevOps. Its network is DevOps net. It's running on the same network as the DevOps, as the MySQL server. And then we have a bunch of environment variables for this. So, and when it launches, it migrates the database to be the latest, loads the data from a recent dump. This is so we can get the latest data from production into our development environment. So if the database has changed, it will make any changes necessary, load the most recent data from production into the database, and then run the Django server. So again, this is a very small step up from simply running a single container. We had Tom Limoncelli in from Stack Overflow last spring, and he was talking about Stack Overflow's setup, and he was showing us that when you hit stackoverflow.com, you're actually hitting one of two sites, each of which runs about 25 or 30 servers doing all various things. There's duplications of some of them, but some of them are a unique service. And Stack Overflow is a minor site compared to Amazon or Google, right? So modern development of web apps relies heavily on things like this, where we're able to coordinate the operation of multiple servers. Docker Compose is one way to do this. Kubernetes is the most popular way to orchestrate whole pods of containers. They call them pods, I assume, because the Docker image is a whale, and whales come in pods, right? A whole bunch of whales is called a pod of whales. So Kubernetes pods are a whole bunch of little Docker whales swimming around in the big ocean of the internet together. All right, so this is all I have. Questions on what we looked at today? I was so startlingly clear that there's not a doubt left in anyone's mind. That's very, very nice. All right, well, that's it for today. Akshay, you can stop the filming if you would.